Welcome to this interactive study guide on pure substances and mixtures. In everyday language, we say a pure to mean something has nothing added, like pure orange juice. But in chemistry, the definition is much stricter. A pure substance is a single element or compound, not mixed with any other substance. For example, pure water contains only H2O molecules. If you dissolve even a tiny amount of salt, it becomes a mixture. This distinction is crucial because pure substances have fixed melting and boiling points, while mixtures melt and boil over a range. Understanding this will help you master separation techniques and analytical methods like chromatography. Let's map out how matter is classified. At the top, we have pure substances, which are either elements or compounds. Elements contain only one type of atom, like oxygen gas. Compounds are made of different atoms chemically bonded, like water. Mixtures are physical combinations of two or more pure substances that can be separated by physical methods. For example, air is a mixture of gases, and salt solution is a mixture of salt and water. Remember, mixtures do not have fixed composition or fixed melting and boiling points. Now let's look at formulations. A formulation is a mixture that has been designed as a useful product. Each component is present in a measured quantity to serve a specific purpose. For example, paint contains pigment for color, solvent to keep it liquid, binder to make it stick, and additives to improve performance. Medicines are also formulations, with active ingredients and fillers. Formulations are common in exam questions, so remember that they are mixtures, not pure substances. Let's go through the key separation techniques. Filtration separates an insoluble solid from a liquid, like sand from water. Crystallization recovers a soluble solid from a solution by evaporating the solvent. Simple distillation boils off a liquid and condenses it, leaving dissolved solids behind. Fractional distillation separates miscible liquids with different boiling points, like ethanol and water. Finally, chromatography separates mixtures of soluble substances, such as dyes in ink. Each technique relies on physical properties like particle size, solubility, or boiling point. Let's work through a chromatography calculation. The RF value, or retention factor, is the ratio of the distance moved by the substance to the distance moved by the solvent front. In this example, the substance moved 4.4 centimeters and the solvent front moved 8.0 centimeters. So RF equals 4.4 divided by 8.0, which is 0.55. By comparing this to known RF values, we identify the dye as dye A. Remember, RF values are always between 0 and 1, and they help identify unknown substances. Watch out for these common pitfalls. First, never use the everyday meaning of pure in a chemistry exam, always refer to a single element or compound. Second, remember that impurities lower the melting point and widen the melting range. Third, in chromatography, the baseline is where you apply the spots, not the solvent front. Finally, when calculating RF values, always round to 2 decimal places. Examiners love testing these details, so be precise. To wrap up, remember that a pure substance is a single element or compound with fixed melting and boiling points. Formulations are mixtures designed for a purpose. You can separate mixtures using physical techniques like filtration, distillation, and chromatography. In chromatography, calculate RF values to identify substances. And know the difference between miscible and immiscible liquids. Master these concepts, and you'll be well prepared for your exams. Good luck!